Hello. Let's check again if audio is good. I couldn't see anything in the video. Yes. Let's try again. Yes. Okay, please check if everything is working fine. And let's start the session now. I hope everything is clear. Okay. Okay, students, let's start the session. In the previous chapters, we have already discussed what is a differential equation and how to find the solution as well as forming a differential equation. In this session, we will start the new chapter, that is vector and 3D. And before that, in the previous chapters, all the topics, especially the last 4 or 5 chapters, involve integration, and some basic standard integral formulas need to be known for solving problems from those units. This is a separate, completely different chapter. You don't need to know any differentiation or integration for this chapter. Just basic coordinate geometry as well as what is a line, point, and such that. Only if you know this, you can easily do this unit. And it is a very simple unit, students, as well as it is a very high scoring chapter for both your board exam as well as your competitive exams. Okay, now let's start with this unit, that is vector and 3D. As the name suggests, we have two separate headings, that is vector as well as 3D. We will be combining both in this session, right? So what is a vector? We will start with, for defining vector, we need to know what is a scalar. What is a scalar? Scalar is a quantity which has magnitude only. You are learning this from class 6, 7. It is a very basic concept. What is a scalar? A quantity that has only magnitude. And what is a magnitude? Magnitude means length or distance. So a quantity that has only magnitude is called a scalar. That means what is a vector? Vector is a quantity that has both magnitude as well as direction. Okay, now suppose let's take, and I'll assume some, wait, we'll see some basic examples. With coordinate system, I am going to explain just two-dimensional coordinate system. You already know how to draw graphs and such. What is a coordinate system? That has both two axes, one is x-axis, another one is y-axis. Suppose the point is x comma y. Okay, now a scalar means that has only magnitude. Say this point is P and this is origin. Origin is nothing but 0, 0. Now for defining scalar, scalar is a quantity that has only magnitude. That means this magnitude OP will give the scalar quantity OP. So OP is a scalar here. And what is OP? It denotes the length or distance of point P from O. Suppose there is another point A. Take A point is here. AP means it is the distance of point P from A. That is the meaning of it. Do you understand? This distance is AP and this distance is OP. So whenever we are talking about scalar quantity, that has only magnitude, or magnitude is nothing but length, right? So that from this itself you can understand this scalar or magnitude will always be positive here, right? Next one is vector. What is a vector? Vector is a quantity that has both magnitude as well as direction. Okay, suppose we want to denote point P in the coordinate system. Then how to do that? We need to know the direction from some other point. Let that point be origin O or A, what is the direction of the point P as well as the magnitude of point P. Then we can define the position of point P with respect to O or A. Do you understand? So what is vector? Vector is a quantity that has both magnitude as well as direction. So here, suppose we want to represent point P. This is a very generic basic example I am giving. So that means we need a direction as well as the magnitude. So that is given by some relative position of another point. Let that point be O or A or any other point. Here we want to find the magnitude of point P from point O or A as well as the direction of point P from O or A. Direction is given by this arrow mark. Right? So this is about vector. What is a vector? I'll again repeat, vector is a quantity that has both magnitude as well as direction. Now let's see some examples for scalar as well as vector. An example of scalar is time. Obviously, time as unit, but we can't give a direction to time. Yes or no? Yes. Mass, similarly, say 50 kilogram, it does not have any direction. Distance, speed, work done. What is work done? Work done is nothing but force into displacement. Okay, let's keep this aside for now. Work done is force into displacement. Force into displacement. Now coming to vector. What are some examples of vector? Current. Obviously, the direction in which the current flows will matter. Similarly, weight. What is weight? Weight is nothing but mass into gravity. Right? So, gravity, again, it is a vector quantity. Acceleration, again it is a vector. Velocity, displacement, torque. What is torque? It is nothing but the rotational force. So the direction in which we rotate, that will matter. So that means torque will be a vector quantity. Similarly, moment. These two are actually interchangeable notations, words. So torque as well as moment are similar in meaning. So what is torque or moment? It is nothing but the rotational force. And you can add force to this. Force is also a vector, right? So because the direction in which the force is applied will matter. We can have a pulling force or pushing force, or force can act in a certain angle. So it depends on that. The resultant will vary. Similarly, work done, that is force into displacement. We already know force is a vector quantity, displacement is also a vector, but when you multiply two quantities, it can become a scalar quantity. Work done is a scalar quantity, right? So these are some examples for scalars as well as vectors. Okay. Representation of vector. In the previous slide I have discussed based on what is, hello sir, are you teaching physics or maths? I am teaching maths, but it is related topic na vector. So we just need to know some basics of physics as well as maths, because you already have a separate unit based on vectors in physics also. You will be solving a lot of problems, right? So what is the difference between torque and momentum? Both are actually very similar in meaning. Torque is nothing but the rotational force. Moment is also a rotational force. Both are interchangeable for your board level. So actually there is a difference between torque and moment, but for both you can interchange that. Both have same meaning. Torque is nothing but, suppose you are having a beam, for example, and you are applying some force at the end of that will create a moment, because that beam will try to bend. You take a wooden stick, try to apply force at the end of this without any support at the bottom, then this will create a moment that will turn this, right? This will turn the beam, correct? So that means this will create a torque. Torque as well as moment have same meaning here, correct? When crash course will start? Crash course will start on 20th of this month, March 20. Okay, so this is about torque and momentum. Now representation of vector. Okay, what is a vector and how to represent vector? We already know what is a vector. Now see how to represent vector. Sir, you are coming after many days. I went to my home for personal reasons. Okay, that's why I was absent. Now let's see this. Here, representation of vector. Generally, we already know vector has magnitude as well as direction. Vector has magnitude as well as direction. So let's give the direction of this line to this, and magnitude, let this be OA. Now this can be written as OA vector, OA, where the direction is from O to A. Always above this vector OA, we will write a line and with the arrow mark that gives the vector OA. Vector is represented like this. Or instead of having 2 points, we can also have a vector like this, vector A. Simply written as vector A. Both are forms of representing vector. Both are correct notations. Okay. So this is about representation of vector. And suppose we have a vector with respect to 3-dimensional space, then with respect to components, we can represent the vector. Now how to represent vector with respect to individual components? This is x-axis, y-axis, z-axis. Let's take I vector is a unit vector in this direction, j is a unit vector in this direction, k vector is a unit vector in this direction. And generally, unit vector will be represented by A cap or OA cap. This cap means it is a unit vector in the direction of A vector. That is the meaning of it, right? So here, let's take I cap is a unit vector in this direction, x, and j cap is a unit vector in this direction of y, and k cap is the unit vector in the direction of z. Can we change unit vector? I didn't understand the question. Mean along x-axis, j. This is nothing but notation. It does not have, you can interchange, but in the conventional wisdom, we follow these conventions, right? Along x-axis, we take I cap, y-axis, j cap, and z-axis, k cap. You can also change the axis, take this as x-axis, y-axis, z-axis. That does not matter. You can take in any way, but the formation as well as the computation should remain the same. This is just about notation, right? In your boards, they will denote these vectors like this, as well as in competitive exams, it is just a notation. Similarly, can we say which angle we are rotating, either in anti-clockwise as well as clockwise direction? Does that matter? Obviously, it matters because that will change the torque, for example. That means here we are representing something with some notation, that is I cap, j cap, k cap. You can obviously interchange, take this as j and I, that does not matter. But this is just notation we follow in convention. Okay. Can we take M and O? Obviously. You can take any letters or alphabets. This is just a notation, right? You have to be clear in your mind. But for board exams, you have to remember, use these notations because they will have your blueprint and everything will be given from this. So you have to denote like this in your boards. That is for sure. Okay. So this is about vector. Okay. Next one is, okay, now how to represent a vector? Say this is a point P. We have to represent point P with respect to this axis, that is 3-dimensional space. Then this can be represented by, in 2D, how do we represent? If you understand 2D, it is just an extension of that for 3D. So we can take x-axis, y-axis, point P. Again, we will take in the direction of x, I cap, and in the direction of y, j cap. Then how to represent point P with respect to O? This will be represented by, let's take this distance as x, some small x, and this distance as some small y. Up to this. This is small y. Okay. Now this is given by magnitude is x, x distance is there, and the direction is I cap, plus magnitude j, magnitude y and j cap. This is generally denoted by x into I cap plus y into j cap. This is representation of vector in component form. Okay, similarly, it is just the extension of two-dimensional plane for three-dimensional space. This is given by OP vector is given by some x into I cap, where x is the distance or projection of this vector, P vector on x-axis. So that will be x into I cap plus y into j cap plus z into k cap. Right? That is it. Okay. This is about representation of vector, either as a notation as well as in component form. Next, what is the magnitude of vector? We have already seen what is the magnitude of vector. It is nothing but the length or distance of the vector from another vector. That is the magnitude, distance between initial and terminal points of a vector. That is the magnitude of vector. It is always non-negative. Obviously, distance is non-negative. Next one is position vector. Again, position vector is similar to this. What is the position vector? Position means we can take a position with respect to or in relation to another position. For example, what is the position of Mysuru? You can't tell what is the position of Mysuru. But with respect to, in relation to Bangalore, you can say it is in the west direction or east direction. Go this much kilometer in this direction to get to Mysore from Bangalore. Do you understand my point? So what is a position vector? We always represent a position vector with respect to another vector. So it represents the position of a point with respect to either origin or some other point. That is the position vector. In a space, three-dimensional space, we generally write position vector with respect to origin. Right? Okay. It is a position of a point in the three-dimensional space with respect to origin. Question. The magnitude of vector 6i minus 2j plus 3k cap is. Okay. What is the magnitude of vector? Magnitude of vector is given by, it is nothing but the distance, and how to calculate distance of point from the origin. So this distance magnitude is given by, there is a formula for this. Let's take the point as A and B, for example, any 2 points, random points, x1, y1, z1 and x2, y2, z2 are the two position vectors. When I write like this, x1, y1, z1 and x2, y2, z2, this means position of point A is this one. With respect to what? Origin, obviously. So this point is nothing but OA vector. And this x value gives the x component, that is the distance is x in the x-axis direction, that is I cap. So this will be x into I cap plus similarly this x1 into I cap, y1 into j cap plus z1 into k cap. This is the meaning of it. A with point means x1, y1, z1 means this is the position of vector A with respect to origin, that is x1 I cap plus y1 j cap plus z1 k cap. Similarly here OB, that is given by x2 I cap plus y2 j cap plus z2 k cap. This is the meaning of it when we write in point form. Okay, is that clear, students? Yes? Okay. Now what do we need to find? Magnitude of vector. Say this distance AB is the magnitude, that is the vector. AB vector is given by, let's take AB vector is this 6i plus minus 2j plus 3k. Now how to calculate AB vector? AB vector magnitude. Magnitude means we'll write within two vertical lines. Magnitude of vector is represented with two vertical lines. This is given by square root of x2 minus x1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square, y2 minus y1 whole square. Just like distance formula, you have already learned in class 11, distance formula, plus z2 minus z1 whole square. There is nothing but the distance, magnitude is nothing but the distance, so this is just the extension of the distance formula in 2D. or 3D, right? So what is the value with respect to origin means here x1, y1, z1 will be 0, 0, 0 and the x2, y2, z2 will be 6 minus 2, 3. So what is the required answer? Magnitude is given by, magnitude of vector is given by square root of 6 minus 0 whole square, that is 6 square, plus minus 2 minus 0 whole square, plus 3 minus 0 whole square, that is 3 square. Now what is the answer? This is 36 plus 4, 40 plus 9, 49. Answer is root 49, which is nothing but 7 units. So what is the magnitude? 7. Answer option C. Easy question now. Obviously magnitude is equal to 6 square plus 2 square plus 3 square root over that value. That is given by root 49, which is 7. Next is types of vector. Again, what are the different types of vector? One is zero vector. As the name suggests, zero means magnitude is 0. That is the meaning of it. When magnitude is 0, that represents a point because we don't have any vector. We can't have any direction for a point. That means for a zero vector, we have point, that is the magnitude will become 0. And we can't take the direction for a single point, right? So that means its direction is indeterminate. So for a zero vector, magnitude is 0, and direction is indeterminate, that is zero vector. And this zero vector is also called null vector or empty vector, and it is generally denoted by zero vector. This is null vector or zero vector or empty vector, all means same. Next one is unit vector. What is the unit vector? Obviously, as the name suggests, unit vector means magnitude is 1. So any vector with magnitude 1 is called unit vector. So here also we can't tell a direction because we can tell a unit vector in this direction, that will be this distance. Similarly, we can form a unit vector in this direction. So direction does not matter. In any direction we can find the unit vector, right? So here unit vector means magnitude is 1. That is the condition. Okay. Unit vector along the vector. We have already seen how to denote unit vector. Let's take this vector as A. Let's take this vector as A vector. A vector is equal to 4 I cap minus 3 k cap. Now what do you need to find? Unit vector along the vector. This word is key. Along the vector. Along the vector means, let's take A vector is in this direction. Along the vector means we have to find a vector in the same direction with the magnitude 1. That is given by what? A cap. And what is A cap? We just have to divide the magnitude to get the unit vector. Direction remains same. Yes or no? So just calculate the magnitude of this vector and divide by the magnitude. So unit vector is given by A cap, which is nothing but A vector divided by magnitude. This is the formula for unit vector. What is unit vector? A cap is equal to A vector by modulus A vector. What is the projection of A on B? We will come to the topic area. Once we started scalar product, we will discuss what is the projection of two vectors. One vector onto another vector. Right? Just hold for some time. We will complete this types of vector, and when we go to scalar product, we can discuss that topic. Okay. A cap is given by A vector by modulus A vector. Now what is the formula here? We need to calculate A cap, that is A vector 4i minus 3k divided by magnitude of this vector is Magnitude of 4 square plus 3 square, which is nothing but 5. So answer is 1 by 5 times of 4i minus 3k. That is it. Easy. So what is the option? 1 by 5 times of 4i minus 3k. Easy questions. So answer is option B. Next question. Find a vector in the direction of vector. Okay, that means direction remains same. So components will also remain same, which has magnitude 21 units. Okay. Now how to find? They have given magnitude 21 units and in the direction of vector. So let's take this vector as A vector then. A vector. Now let's take B vector as the required vector. B vector is nothing but some magnitude, that is 21, into direction is A vector, that is A cap. Unit vector in the direction of this vector will be A cap multiplied by its magnitude. That will be the answer. Yes or no? This is given by 21 into this A cap is nothing but A vector divided by modulus of A vector. That is given by 21 into what is modulus A vector? Modulus A vector is 2 square plus 3 square, that is plus minus 3 square, which is again 3 square plus 6 square into 2i cap minus 3j cap plus 6k cap. Now what is the answer for this? This is 9 plus 36 plus 4. Again it is 49. Root 49 is 7. So answer will be 21 by 7 into 2i cap minus 3j cap plus 6k cap. Okay, 21 by 7 is 3. So final answer is 3 times of this vector, which is 6i cap minus 9j cap plus 18k cap. That is it. Easy. 6i minus 9j plus 18k. Do you understand? Once you understand the question, answer is very easy in solving for vectors. Next one is free and localized vector. What is a free vector and what is a localized vector? In the previous example, we have seen two types. One is writing the notation as AB as well as writing the notation as A vector. What is the difference between writing like these two? Here when we write A, B vector, A and B are position vectors of point A as well as point B. When we write small a, then we can't determine a position for this. What I try to mean by that is, for a vector, if its position is fixed, that means we have one point, at least one point fixed, say A point, and we know the direction, that is along B vector, along point B, and this is the vector given by this. So that means AB vector is nothing but a vector from point A to point B with this much magnitude, that is magnitude of AB. Okay, and direction is from A to B. That is the meaning of it. Take another vector which is similar and it is given by A vector. Are these two same? It may or may not be same. I will give one example. Let's take point A as given by 1, 1, 1. Point B is 3, 3, 3. Then what is AB vector? AB vector is given by 3 minus 1, that is 2 I cap, plus again 2 j cap, plus 2 k cap. This is AB vector. Do you understand how to find AB? You already know this. Next, what is, take another vector which is some small a vector or small c vector, which is equal to, again we will take the same vector, 2i cap plus 2j cap plus 2k cap. But here the position of this, there is no fixed position for this vector, A vector. For AB vector, position is 1, 1, 1 for point A and 3, 3, 3 for point B. That means both these positions are fixed, and we also have a direction that is from point A to point B. So that means AB vector will be a fixed vector. Do you understand the difference? Where this A vector is a free vector. So what is a fixed or localized vector? Its position is fixed. That is a localized vector. Free vector means its position is not fixed. That is the difference. So when there is no restriction to choose the origin of a vector, that means if initial point is not fixed, then it is a free vector. Otherwise, it is a fixed or localized vector. Okay. Next is co-initial as well as co-terminal vectors. Co-initial vector means vectors with same starting point. Two vectors like this are co-initial vectors. OAB. Then OA and OB are co-initial vectors. Co-terminal vector means vectors with same terminal points. Again, let's take this as A, B and C. Then AB vector and CB vector are co-terminal vectors. Example is OA vector and OB vector are co-initial vector. For co-terminal vectors, it is CB vector and AB vector. AB vector and CB vector. These two are co-terminal vector. Co-initial means first value is same. Co-terminal means second point is same. That is the difference. Okay. These are all easy topics. Collinear or parallel vector. What is a collinear or parallel vector? It is again vector which has the same direction or the opposite direction. That is the parallel. When you say two lines are parallel, because when they have same direction, when the angle is same, then we can say two lines are parallel. In vectors, we don't talk about angle as such because we are mainly dealing with three-dimensional space. So we don't talk about angle as such. Instead, what we'll use the term direction. So here, when vectors have the same direction or the opposite direction, we will take that vectors as parallel vectors. Parallel vector is nothing but collinear vector, right? So what is parallel vector? Vectors with same or opposite direction to the given vector. In that, there are two types. One is like vector and unlike vector. Like vector means vectors with the same direction. Both the vectors have same direction. Unlike vector means both these vectors have opposite direction. Right, that is it. Two vectors, A vector and B vector, are collinear if. Okay. When we can say two vectors are collinear, that means it is a parallel vector. When we say two vectors are parallel, when we have same direction or opposite direction. And suppose vector is let's take the vector as 1 I cap plus 1 j cap plus 1 k cap. I am giving one example. B vector as 3 I cap plus 3 j cap plus 3 k cap. Now this vector can be written as 3 times of I cap plus j cap plus k cap. Yes or no? Yes. Are these two parallel? We have already seen in the magnitude of vector. Here direction remains same. Say I plus j plus k direction is this one. And there is another vector. A vector is I plus j plus k. B vector is 3 times of I plus j plus k. That means components is same. So direction will remain same. But magnitude changes. Are these two parallel vectors? Yes. So what is the difference here? Only magnitude will vary, direction will remain same. As the magnitude only varies, we can write this value as some lambda times of this vector. A vector is equal to lambda times of B vector, or B vector is equal to lambda times of A vector. This is the condition for parallel or collinear vectors. So how to say if these two vectors are collinear? Then what is the condition? B vector by A vector should be some constant, or this vector is taken as A1, B1, sorry, A1, A2, A3 and B1, B2, B3, then the corresponding ijk component ratio should be proportional, yes or no? So here we will get A1 by B1 equal to A2 by B2 equal to A3 by B3. So what will be the option? Option B is the correct answer. Yes or no? I hope this is clear for you. What is a parallel vector? When two vectors have same or opposite direction. That means its corresponding components will be in proportional. So that means A1 by B1 equal to A2 by B2 equal to A3 by B3 is the correct answer. Next one is addition of vectors. Okay, when we will say two vectors are added, then what is the resultant vector? Resultant vector can be given by two laws. One is triangle law of addition or parallelogram law of addition. There is one more law which is polygon law of addition. All these three are nothing but extension of triangle law of addition. What is triangle law of addition? Let's take two vectors, A vector and B vector, in this direction. Say from point A to B and then from B to C. AB vector is A vector and BC vector equal to B vector. Then the resultant vector is given by AC vector, which is, let's take this as C vector. Now by triangle law of addition, this resultant vector C vector is nothing but the closure of AB as well as BC vector, but in opposite direction. What do you mean by that? A vector plus B vector. Suppose we take AB plus BC, AB, BC, then we have to close this figure by going from C to A, right? So when we can close this figure from A to B, we are moving, that is A vector. From B to C, it is B vector. Then change the direction, that is closer, which is CA vector. But the resultant vector is the opposite of closure, which is nothing but AB plus BC equal to AC vector. Right? Here when you observe how to add directly, here the terminal point of first and the initial point of second vector is same. Then the resultant is given by, take the first point in the first vector and the last point, that is terminal point in the second vector, that is the resultant. This is the triangle law of addition. Next one is parallelogram law of addition. Again it is similar to triangle law. Let's take these points as A, B, C and D. Let this vector be A vector and B vector. Then obviously the diagonal AC is given by, diagonal AC vector is given by, let's take this as C vector, AC vector is C vector, then it will be given by A vector plus B vector by triangle law of addition, we already know. Then what about the other diagonal? The other diagonal BD vector will be given by, BD vector will be given by, now this vector is given by what? We just have to take the opposite direction of this and close this figure. These two are in same direction, BC and AD, as this is a parallelogram law of addition. This is a parallelogram. BC magnitude and AD magnitude will be same. That means when we take this direction, it is also B vector. And what about AB vector? AB vector is A vector. Then what about the other direction? That is CD vector, which is given by minus of A vector. Correct or no? Yes. So what is the resultant? Resultant is given by, this vector will be minus of A vector when you go from AB in this direction, then that will become, we should not write it like this. Instead, by vector representation or notation, we will write this as BA vector. This is nothing but minus of AB vector, which is nothing but minus of A vector, minus of A vector. So what is the resultant? It is minus A vector plus B vector, minus A vector plus B vector. or B vector minus A vector is the other diagonal. Correct. So this is parallelogram law of addition. One diagonal is given by A vector plus B vector, another diagonal is given by B vector minus A vector. Next is polygon law of addition. It is again the same, just a extension of triangle law. Instead of 3 sides, we have n sides. Then the last side will be the resultant of except the closure but in opposite direction. That will be the polygon law of addition. Okay. That is not required for now. ABCD is a rhombus whose diagonals intersect at E. Then EA plus EB plus EC plus ED vector is given by. Okay. Let's take this as rhombus. ABCD is a rhombus. ABCD is a rhombus whose diagonals intersect at point E. Okay. ABCD is a rhombus whose diagonals intersect at point E. What is the condition for rhombus? All sides are equal and diagonals bisect each other. We know the two conditions. All sides are equal and diagonal bisect each other. Now how to find this value? EA, EC, EB, ED. We have to find EA vector plus EB vector plus EC vector plus ED vector plus ED vector. Now this value can be written as point E is the initial point from here. So EA vector will be this one. EB vector will be this one. EC vector and ED vector. By observation itself you can tell. As diagonals bisect each other in a rhombus, this EA vector will be minus of EC vector. Correct or no? Diagonals bisect means E is the midpoint of AC. So EA vector and EC vector have same magnitude but opposite direction. Similarly for EB as well as ED vector. So when we add all these values, what will we get? EA vector is nothing but minus of EC vector minus of EC vector. Similarly, ED vector will be minus of EB vector minus of EB vector. Now when we add all these, EA, that is minus EC plus CC will get cancelled, minus ED plus CD will get cancelled. So what is the answer? This answer is 0 vector. EC, because by property of rhombus, diagonals bisect each other and all the sides are equal. That is it. Easy questions. Since diagonals bisect each other in a rhombus, when we add all this, EA and EC will get cancelled out. Similarly, EB and ED will get cancelled out. Next one is section formula. We have two types of section formula. Just like in coordinate system, straight lines, you have already learned in class 11. We will use the same concept here. Whatever we learn in vectors, that is until now we have seen distance formula and now we are going to see section formula. Both are similar, right? Based on just coordinate systems. Here in the coordinate system, we have learned about two-dimensional planes, that is XY plane, and in that you have learned distance formula and section formula. Here we will be discussing about three-dimensional space. Again, it is same for internal section as well as external section. Formula remains same. How do we calculate internal section? Say C is the point that divides AB. C is the point that divides AB, line AB, in the ratio m:n. Then the position vector of point C, that is C vector, is given by m into, we will take the other point B vector, plus n into A vector divided by, add this ratio, that is m plus n. This is the section formula for point C. What is the point C? Position vector of point C is given by m into B vector plus n into A vector by m plus n. This is internal section. Similarly, external section is given by m into B vector. Here, when we talk about external section as well as internal section, always remember this M is the distance or the ratio of point A up to point C. Similarly, for external section, M will be from point A up to point C, and N is the part that corresponds to point C from point B. This is M and N in this formula. Is that clear? Don't take AB as M and BC as N. That is a common confusion that students have. So, for making this very clear, always take whichever point that divides the line. Here point lies outside, that is why it is called external section. Then from that point up to the initial point, that is M, and the last point, that is N. So the ratio is from A to the point that divides. AC is M value and BC is N value. And position vector point C is given by C vector is equal to, again, M into last vector. Here last vector is B vector, M into B vector, again N into A vector, but here as point lies outside, we will have minus sign. Minus of, again, M minus N. Proof is not required for you, just note down the formula. That is enough. Okay, again I will repeat. In internal section is given by this formula, M into B vector plus N into A vector by M plus N. External section is given by M B vector minus N A vector by M minus N. Again, this B vector, C vector, A vector are position vectors in the previous slide. These are all position vectors. Now instead of position vector, suppose there is some other point from which they have given PA and PB vector. What is the position vector of point C with respect to point P? That is PC vector. Formula remains same. What we wrote there? Here M into B vector plus N into A vector by M plus N. What will be the formula for this? Again same, M into B vector plus N into A vector. Write it as it is. M C vector is equal to, write it as it is. C vector is equal to M into, M into B vector plus N into A vector by M plus N. Write the formula as it is. But here, with respect to what is the initial point? P. So write P here. PC vector is equal to M into PB vector plus N into PA vector by M plus N. This is the easiest way to remember this. Similarly here, AD is the median. Median means midpoint. So for a triangle, this is just an application. How do we use this section formula for writing the answer of median directly? So again, AD vector is given by, as D is the midpoint of BC, we can write D is equal to B plus C by 2. Yes or no? B plus C by 2. We don't know vector. I am not writing vector as of now. Just observe. D is the midpoint of BC. That means B plus C by 2 is point D. Yes. With respect to whichever point we did, we can write with respect to O or A or whatever point. So if we write with respect to A, then AD vector will be AB vector plus AC vector by 2. That is it. Then AD vector is nothing but the median vector. We directly get the answer. Is that clear, students, how to do that? Yes, this is just an application of how to find median. Most questions can be asked based on this. Yeah, 2 more question or 3 more question can come from this topic. Find the length of median AD vector. Again, that is given by, first we have to find the midpoint of this and then calculate. Directly find AD vector and then do the magnitude. That is, you already know how to calculate distance. Easy. The position vector of 2 points A and B are given by, okay, the position vector of point P which divides the line segment joining A and B in the ratio. Okay, sir. Line is given, OA vector is given, so let this be A point and B point. O is origin, let it be here. OA vector, OB vector is given. What is the coordinate? OA vector is given by 2i cap minus j cap minus k cap. I am writing this in point form. Similarly, OB vector will be 2i cap minus j cap plus 2 k cap. I hope this is clear how to write this. Okay, now what do we need to find? The position vector of point P which divides the line segment joining A and B. Okay, point P is here. Position vector of point P means OP vector which divides AB in the ratio 2:1. From A there is 2 part, so this is 2, and from B 1 part. As this point divides AB internally, then what is the answer? Obviously we can write P is equal to 2 times B plus 1 time into A divided by 2 plus 1, that is 3. And what is this point with respect to O? So it is OP vector, OB vector, OA vector divided by 3. Now we can directly write, this is not 10, this is 1 into OA vector. Okay. Now how to find this? Obviously it is very easy. 2 times OB vector, that is 2 into 2, 4, plus 2, 6, I cap. Next is again 2 times, that is minus 2, minus 1, minus 3. 2 times into 2, 4, minus 1, that is 3, k cap, divided by 3, which is nothing but 6 by 3 is 2, 2i cap, minus j cap, plus k cap. This is the answer. Easy question now. So we can write directly. This is just a section formula question. 1 time into first point plus 2 times into second point divided by 3. 2 plus 1. Next question is the position vector of a point which divides the line joining points externally in the ratio. Okay, sir. What is A minus 2B vector? Do we have A vector and B vector? No, nothing is given. So let's take this point as P and Q. We don't know the point. This is nothing but A minus 2B and this is 2A plus B. Okay, sir. Next, what is given? This line is divided, PQ is divided, position vector of a point which divides the line joining the points with position vectors externally. This is the keyword, externally. So that means let this point R divides PQ externally. So point R lies outside PQ. And what is the ratio? 2:1. So from P up to R is 2 parts and from Q it is 1 part. Okay, sir. Now what is the answer? Position vector R vector is given by, let's take this as R vector, that is given by 2 times of this Q vector, that is 2A vector plus B vector, minus of 1 time of this side, that is A minus 2B, A vector minus 2B vector, divided by 2 minus 1. Now what is the answer? This is 2 into 2, 4A minus A is 3A. Again 2B plus 2B, that is 4B. So what is the answer, students? It is 3A vector plus 4B vector. That is the required answer of position vector point R. Right? What is the answer? 3A plus 4B vector. Again, procedure is same. It is very simple concept. Vector is a very high scoring as well as the easy topic. The two vectors j plus k and 3a minus j plus 4k represent the two sides AB and AC. Okay. Of a triangle ABC. Let's draw a triangle ABC. And what is given? Two vectors j plus k, that is AB vector. AB vector is j plus k. This is j vector plus k vector, j cap plus k cap, and the other one is AC, which is 3i cap minus j cap plus 4 k cap. Okay. Find the length of median through A. Median through A is given by this. Let this point be D. And median is AD. What we need to find? Median through A. That is AD vector magnitude. This is what asked in the question. Okay. Now, we already know D is the midpoint of BC. Since D is the midpoint of BC, we can write D equal to B plus C by 2. D is equal to B plus C by 2. And with respect to A, we can write AD vector is equal to AB vector plus AC vector by 2. Yes. And what is AB vector? AB vector is given by this. And AC vector is also given, divided by 2. Which is nothing but 0i cap plus 3i cap. 3i cap, then j cap minus j cap, 0 j cap, 0 j cap. Next, plus 1 k cap plus 4 k cap, that is plus 5 k cap, divided by 2. Okay, sir. Next, what do we need to find? Magnitude AD. Magnitude of AD is given by square root of 3 by 2 square plus 5 by 2 square. Obviously, 1 by 2 is outside. We can take it outside and find the magnitude of remaining. That will be 3 square plus 0 square plus 5 square. Now, this is equal to 9 plus 25, 34. 1 by 2 into root of 34. That is it. Easy. So answer is root 34 divided by 2. Okay, sir. What is the answer? Root 34 divided by 2. Just take AB and AC. We already know the position vector of these points. So we need to find D vector. Instead of finding D vector and then calculating AD vector, we can directly take AD vector. Here point A is not given, so in this solution they have assumed point A as origin. Then obviously B and C will be the position vectors given by this. Then also we can do. It does not matter how do we solve. As long as answer is okay, you can assume any point and then try to solve. Or just like how I did in the previous slide, you can use that method also, right? As long as the answer will be same. Answer should be same anyways. Next is scalar product. Now we can discuss Arya's topic, that is projection of A vector on B vector. First we will go through what is scalar product and then we will come to that in a consecutive slides, in the consequent slide. Okay. First one is A vector dot B vector. That is equal to, the formula is given by modulus A vector into modulus B vector into cos theta. As the name suggests, it is dot product. That means we are taking dot here in between vector, and it is a scalar product. That means answer should be scalar. When you multiply two vectors, answer becomes a scalar. That is why it is called scalar scalar product. And what is scalar product? A dot B is given by mod A mod B cos theta. Obviously, magnitude does not have any direction. Similarly, modulus B into cos theta. That means the entire value is some value. It does not have any direction. That is why it is called a scalar product. Right. So A dot B is given by modulus A modulus B into cos theta. Or in component form, that is given by AX into BX, that is X component, plus multiply the Y components plus multiply the Z components and add all this. That is given by A dot B. Here, what is angle? This theta is nothing but angle between A and B. Here, let this be A vector and B vector, then theta is the angle in between these two vectors. Now, this is an acute angle, so this becomes theta. What about if it's an obtuse angle? Then again, A vector is given by this, B vector is in this direction. What is the angle between A and B? Angle between A and B is this angle. Correct. Angle between A and B is this angle, that is alpha. When we take theta, this is obviously acute angle. But what is the angle between A and B? It is an obtuse angle. So when we take about this value alpha, here in this formula it will become alpha actually. This is not theta here because this theta gives the acute angle between A and B. This alpha gives the obtuse angle, that is the angle more than 90 degrees. So here we will get this value A not B cos theta will be a negative answer as cos theta is negative in the second quadrant. In this case it is positive. Therefore we can assume if cos theta angle is 90 degree, it can also become 0 as cos 90 is 0. That means this scalar product A dot B can be either positive value, 0 or negative value. It can have all types of values, right? All real numbers are possible for scalar product. So this is how we define scalar product. And what is the angle between A and B? Obviously A dot B is equal to this value. A dot B is given by this value, which means what is the angle? We can write cos theta is equal to, I'll write it here, cos theta will be equal to A dot B by mod A mod B, A dot B by modulus A vector into modulus B vector. And what is theta? Theta is cos inverse of this value. Theta is equal to cos inverse of A dot B by modulus A vector into modulus B vector. This is the angle between two vectors that is given by cos inverse of A dot B by mod A mod B, right? So this is the formula given, okay? And this angle can be either obtuse or acute angle or right angle based on the value of cos theta. If cos theta is negative, obviously this is obtuse angle. If it is positive, acute angle. 0 means perpendicular. Now the properties of scalar product. What are the properties of scalar product? Obviously scalar product is commutative. What do you mean by commutative? A dot B equal to B dot A. Obviously in the previous slide we have multiplied A dot BS AX BX plus AY BY plus AZ BZ. When you talk about B dot A, here we will get BX AX. A into B is same as B into A. Similarly, BY AY, BZ AZ. So answer will remain same or not? Yes. So this is commutative. Next property is scalar product is distributive over addition. What do I mean by that? Distributive over addition. That means B plus C, it is addition, and this product, scalar product, is distributive. That means we can write A dot B plus C is equal to A dot B plus A dot C, just like how we write in numbers. Next property is L and M are some scalars, that is some non-zero numbers. Then L into A vector dot M into B vector can be written as, we can take the scalar numbers outside and then write A dot B. When you observe this, you can easily tell if it is true or not. Yes. We can take, anyways we are going to only multiply the corresponding components, and this L and M are multiplied throughout those vectors A and B. So we can take that outside. Now what are the other properties? A dot B is greater than 0 means obviously mod A mod B cos theta is positive, which means cos theta is positive. That means angle is less than 90 degrees or acute angle. Angle is acute. Similarly, when dot product is negative, angle will be obtuse. When dot product is 0, angle is 90 degrees. This is very, very important, students. A dot B equal to 0 means A and B are perpendicular to each other. In the questions, they will give A and B, two vectors are perpendicular to each other, and we will have to use this condition, A dot B equal to 0, right? Next one is A dot A. Obviously, what is the angle between this? Mod A cos angle is 0, cos 0 is 1. That means it is nothing but modulus A into modulus A, which is modulus A whole square. Similarly, A plus B whole square. We can use this property to get this answer. This is nothing but modulus A whole square is A dot A. Similarly, modulus A plus B whole square is A plus B dot A plus B, which is nothing but A square plus B square plus 2 times A dot B. By using this property now, right, you can try this yourself. It is very simple. Similarly, A plus B plus C whole square, that is equal to A square plus B square plus C square plus 2 times of A dot B plus B dot C plus C dot A. Simple question, students, very easy properties, but it is very important also. You have to remember this. Next is a question. If theta is the angle between vectors A and B, then A dot B is greater than or equal to 0. Theta is the angle between the vectors A and B, and A dot B is greater than 0 only when will you get A dot B is greater than or equal to 0? That means from this we can write modulus A modulus B vector and cos of angle is theta, which is greater than or equal to 0. Yes or no? Obviously these two are greater than 0. This is always greater than 0. That means cos theta is greater than or equal to 0. Yes or no? Yes. And when will you get cos theta is greater than 0? When theta lies between 0 to 90 degrees. When theta lies between 0 to 90 degrees. Now comes the question, should we include the boundary values 0 and 90 or not? What is cos 0? 1. And can cos theta become 1? Obviously it can become 1. So that means we can include 0. And what about 90 degree? Cos 90 is 0. And here cos theta should be greater than or equal to 0. That means we can include 90 also. So what is the answer? 0 less than or equal to theta less than or equal to 90 degrees, pi by 2. We have to be careful about choosing from these two options, as these two look very similar. You may commit mistake while marking, but the correct option should be option B, right? A mod B cos theta is greater than or equal to 0. That means cos theta is greater than or equal to 0. So what is the range of theta? That is between 0 to 90 degrees. I, J, K are unit vectors along 3 mutually perpendicular directions. Okay. I, J and K are 3 mutually perpendicular vectors. Then what is the relation? We have already seen when 2 vectors are perpendicular, what is the condition? Dot product is 0. Yes or no? Yes. This is mod I, mod K, cos 90 degrees, as I, J, K are mutually perpendicular. That means what is cos 90? It is 0. So what is the correct option? Option C. Easy question, students. These are all just properties, and they are asked in one more question in your board exams. Right? Simple questions. So what is the correct option? Option C. Next question is, if A, B, C are unit vectors such that A plus B plus C equal to 0, write the value of A dot B plus B dot C plus C dot A. Okay. Now this is again another important concept and important model or format for solving problems. First, what we need to observe is, in the same question they can ask find the angle between A and B. That is one possibility. Or they can ask to find what is A dot B value. Question can be framed in any ways, but by looking at the question what is asked in that and the given condition, try to establish a relation between those two. That is the first step. Here what is given? A plus B plus C equal to 0. And then we have to find A dot B plus B dot C plus C dot A. Now how to find this? A plus B plus C and AB plus BC plus CA. What is the relation? Obviously, A plus B plus C whole square will have this formula. Yes or no? Think about algebraic formulas. Then we can write A plus B plus C whole square equal to, take modulus and square this. Modulus value will be 0 and its square will be also 0. So that means this value is 0 and this is nothing but A plus B plus C dot A plus B plus C. A plus B plus C equal to 0. Now what is this formula? Mod A whole square plus mod B vector whole square plus mod C vector whole square plus 2 times of A dot B plus B dot C plus C dot A. Okay, this value is equal to 0. Now what is this? 1, 1, 1, as these are unit vectors. So this will be 3. These 3 values will 3 plus 2 times of, let's take this value as K. 2K equal to 0. Now what is K? We have to find K. This is, let's take this as K. Which means what is K? K is nothing but minus of 3 divided by 2. That is our required answer. Simple. What is the required answer? Minus 3 by 2. So first thing we have to understand in such type of question is, see the question and the condition. How to get the question from the condition. That is it. So answer is minus 3 by 2. Next question is, A and B are 2 unit vectors such that magnitude 2A minus 3, 2A plus 3B equal to magnitude 3A minus 2B. We have to find the angle between A and B. This is what I told in the previous question. Questions can be framed in any ways. Now this is angle between A and B. We have this condition. What we can do, as magnitude is same, its square should also be same. Yes or no? Yes. So 2A plus 3B magnitude square will be equal to 3A minus 2B magnitude square. Now with this we can write this as magnitude of 2A whole square plus magnitude of 3B whole square plus 2 times of 2A dot 3B. 2A dot 3B. Now this is equal to magnitude of 3A vector square plus magnitude of 2B vector square minus 2 times of 3A vector dot 2B vector. Okay, sir. Now this is nothing but 2 times, these two are unit vectors, A and B are unit vectors. So magnitude is 1. This is nothing but 4A square, 4 into 1 plus 9B square plus, we can take 2 and 3 outside, so it will be 12 into A dot B. 12 into A dot B, which is equal to, again 9 plus 4, 9 plus 4 minus of 12 into A dot B. 12 into A dot B. 9 plus 4, 13 and 13 will get cancelled out. 12 A dot B equal to minus 12 A dot B, which means obviously A dot B equal to 0. A dot B equal to 0. Okay, sir. Now A dot B equal to 0 means what is the angle between A and B? Obviously angle is 90 degrees perpendicular. Yes or no? Very simple question. Angle is 90 degrees. Angle becomes 90 degrees. Just solve using this procedure. And this concept is again very useful. Whenever we have modulus given, in most of the questions, depending on what is asked, we just have to square this and write mod A square equal to A dot A. That is it. Then you will get the answer as simple as that. This is standard approach or procedure for solving these problems. Next is geometrical significance of dot product. Here comes the question asked by the student. What is the geometrical significance of dot product? Which is nothing but projection of vector. Projection of A vector on B vector. Let's take it like this. Geometrical significance is projection of, say, vector A on vector B, or vector B on vector A. Vector A on vector B. That means this is A vector and let this be B vector. What is the projection of A vector on B vector? That is given by, this is the projection. So what is the projection? Projection gives the length, this length. Or you can also call this projection as shadow. Yes or yeah? Is that clear? What is projection of A vector on B vector? It is nothing but we are projecting this vector onto the other vector. We are projecting this A vector onto B vector, right? So this projection is given by this magnitude, which is the shaded blue region, right? So what is the magnitude of this? How we can write a relation established from A vector and B vector from this? Obviously, this total length is, let's take this point up to this point as B vector. Then the direction, in the direction of B vector, a unit vector will be given by B cap. Yes or no? Yes. So we can write B cap is the vector that is in the same direction but magnitude is 1. Next, what we need to do, we have to multiply this length with this direction to get this blue shaded region. Yes or no? How to get that? It is nothing but we are going to project this A vector onto this portion. Now this is given by, if the angle is theta between these two, then this total length is given by shaded region is mod A. This shaded region is given by mod A, that is this total length into cos theta, as cos theta is adjacent by hypotenuse. This is adjacent and hypotenuse. So what is adjacent? It is cos theta into hypotenuse, that is modulus A, this total length, into it is projected onto adjacent, that is mod A cos theta. Now this is nothing but total distance will be B cap multiplied by mod A cos theta, mod A cos theta. Now what is B cap? B cap is nothing but B vector by mod B vector. This is equal to B vector by modulus B vector. Now this is given by B vector dot A vector cos theta. Take magnitude here. Now this is given by, this formula is A dot B divided by modulus B vector. This is the projection of A vector onto B vector. So whenever we are projecting this vector, A vector on B vector, this, what is the vector that is projected in the direction, that direction will be divided here. So here A vector on B vector means divided by magnitude of B vector, A dot B by modulus B. Good afternoon, sir. RB family. Good afternoon, RB. How are you? So this is the projection formula. Clear now? So what is B dot A by mod B? That is given by projection of A vector on B vector. Now what is projection of B vector on A vector? Again it will be B dot A by mod A. Same formula, but whichever vector onto which we are projecting, we have to divide by that. Simple. Okay, this is about projection. Now let's do some problems for understanding this concept. If A vector is given by 2i minus j plus 2k and B vector is given by 5i minus 3j minus 4k, we should find the ratio. Projection of A vector on B vector. We can directly write what is A vector on B vector. A vector dot B vector divided by modulus B vector, as this value should be divided magnitude of B vector, divided by what is the next value? Again projection of B on A, that will be B dot A divided by modulus A. Again A dot B, B dot A, same value. So this is nothing but modulus A vector by modulus B vector. We already know how to calculate modulus. What is the magnitude of A vector? Square root of 4 2 square plus 1 square plus 2 square divided by square root of 5 square minus 3 square plus 4 square. Okay, this is equal to 4 plus 1 5 plus 2 7. 4 plus 4, now this one 2 square, sorry. So this value is 9, root 9 is 3 divided by, here we get root 50. Root 50 is nothing but 5 root 2. 5 root 2. Or this can be again written as multiply and divide by root 2. Then we will get 3 root 2 divided by 5 into 2, that is 10. Either you can write 3 by 5 root 2 or 3 root 2 by 10. That is the answer for us. Right? So this is the projection of A vector on B vector divided by B vector on A vector. So what is the answer? 3 root 2 by 10. First find the projection. Either you can calculate A dot B and then find the numerator separately, denominator separately, and then divide. Or you can just divide this. Anyways, it is same as A dot B will get cancelled. It is nothing but simply mod A by mod B. Both ways answer will remain same. Next question is, if A vector is given by this and B vector is, then find the projection of A on B. It is same as previous question. We will directly see the solution. What is projection of A vector on B vector? A dot B by modulus B. And what is A dot B? A dot B can be calculated by multiply the corresponding components. 7 into 2, 7 into 2, that is 14. Next one is 1 into 6, that is 6. Minus 4 into 3, that is minus 12. Divided by, what is the value? Modulus B. What is mod B? 4 plus 36, 40 plus 9. 49 square root is 7. So divided by 7. Now what is the answer? 14 plus 6, 20 minus 12, that is 8 divided by 7. Simple question. Just the direct substitution or application of formula. Right? Next one is cross product. We will start from cross product in the tomorrow's session, students. And thank you. Always keep learning and keep growing. Success is yours line by line. Endigu endendigu namma tapasya. Thank you, students.